We'll start with a short video talking about the concept of migrating data to the cloud and the challenges that get associated with that. Obviously, people are looking at lifting and shifting and making that move up into the cloud. We've gotten over the concerns around cost of cloud, the concerns around security of the data in the cloud. And then the next question that comes along once you start to look at that is, well, what about moving data that's constantly changing up into a cloud platform, whether that's Amazon or Azure, what have you? How do we do that without stopping that data from being accessed and lifting and shifting it up into the cloud? And more recently, we've begun working with Databricks as well to help convert, for example, Hadoop workloads from Hive, for example, into a Delta Lake format. And the reason that we're looking at doing this is obviously people have been looking at their on-premise Hadoop investment, looking at what's happened with MapR, looking at what's happening between Cloudera and Hortonworks and the merger of the two, and wondering just what the longevity of the Hadoop ecosystem really is. And can we move that up into the cloud and kind of avoid some pain in the process of doing that? Which brings us to the concept of how do we actually do that? And recently we were speaking with a potential business partner, and we asked them the question about how do you do this today? How do you help customers take their data up into the cloud? And the answer that came back was, we throw people at it. So we do a lot of coding, we develop a lot of scripts, and we spend a lot of time taking this data and moving it up and making sure, and here's a key word, that it's absolutely consistent in the cloud with what's on premise, so that you can ask the same question of your on-premise infrastructure and the same question in your cloud infrastructure and get the same answer at any given time. And that is a huge challenge when you're trying to do something manually. Other solutions from Microsoft, they've got Databox. Amazon have got Snowball, which is basically a big, huge hard drive that shows up at your data center. You throw all your data on it, put it on the UPS truck, and it goes up into the cloud. Okay, great. If that data is static on premise, that's a good solution. But if the data that you have on premise is constantly changing, by the time that data transfer device has reached your cloud object store, it's probably 1 week, 2 weeks out of date. So now you have to reconcile the differences between what left your data center on the data transfer device and what's changed in the meantime. Another potential approach is to do a combination of the manual approach, where you have your data transfer device and then you write a bunch of scripts that try and do a delta of what is on the data transfer device opposed to what's changed since the data transfer device left the data center. Again, a very manual and labor-intensive process. So this is where we come from, is being able to use, as it says, Live Migrator, to move data into the cloud while it's changing. And why is that important? Well, you can see here that you could have business disruption as part of this. You might have to kick all of your users off the system to stop the data from changing while you're trying to migrate into the cloud. And if you're trying to do that at petabyte scale, that's 85 days or 90 days worth of outage just so you can move the data to the cloud. That's not going to work in a modern business context. You have the risk of losing data. You're migrating up into the cloud, you think, yep, I've got it all there. You shut down your on-prem and you realize, oh my God, there's a whole data set that's missing and we don't have it anymore, which potentially is going to have a hugely negative impact. And obviously with a manual approach to writing all these scripts and using layers and layers of people to try and achieve this, you're really spinning up a lot of cost and you're really losing a lot of IT resource to what effectively is just data movement. So we really want to avoid that particular set of circumstances, and we want to be able to move data while the business remains productive and you're ensuring business continuity. We want to make sure the data is 100% consistent between what has moved from on-premise and what has moved into the cloud. And we want to automate that as much as possible so that we're not throwing resource after resource after resource at the particular problem. And the way that we're seeing customers transition this is initially migrating up into the cloud and moving large data sets. And then for a period of time, what they will do is they will run in a hybrid mode. So they'll be doing a little bit of compute on premise. They'll be doing a little bit of compute in the cloud, maybe doing some UAT to make sure the application workloads are delivering the results that are required, that the security is right, and then start to gradually transition the user community from the on-premise environment into the cloud environment, and then ultimately shut the on-premise environment off. And we've got several examples of where we've helped customers do exactly that with no disruption to the business. And then moving forward in the longer term, taking a strategy whereby we think that maybe sometimes there's problems with Azure, or sometimes there's problems with Amazon S3, which there have been historically. So taking an approach where you could use multiple different clouds to house the exact same copy of your data. You're leveraging the application stacks that you have in Azure, the application stacks that you have in the Amazon marketplace, deriving different value out of those, and synchronizing the data between those cloud environments, whether that's within a single cloud provider, multi-region Azure, multi-region Amazon, or multiple cloud vendors, so you're avoiding the concept of vendor lock-in. So this is what we enable on the broader scheme of things. Now what I'd like to show you, and I wish the audio was working because you could hear Paul talking to it a little more succinctly, is an example of us taking on-premise Hive data and converting it to Databricks Delta Lake format and querying the results and seeing the results are actually the same between the two. So on the left-hand side, what we see is a Hortonworks environment running Hive, obviously. We're going to kick off a Hive job using Tez here in a few minutes. And on the right-hand side, you can see in Azure, we've got Delta Lake running. The database at the moment is empty, so what we're going to do is obviously create some tables here very shortly. Pardon me. So we're just going to show that the retail demo is actually empty at the moment. There's no tables in there. There's no data. So the first thing that we're going to do is an insert statement on the Hortonworks side of things, and that will be coming up here shortly. So here comes our insert statement. So that needs to be written into Hadoop. And as it's being written into HDFS and the Hive Metastore, data is actually being replicated in real time into the Azure Data Lake Store and being converted into Delta Lake format. And you can see here that now when we refresh the view, we actually have our table visible. And we can start to run queries against this data and compare what we see on premise versus what we're seeing in the cloud. And the interesting thing about this particular demo is going to kick off the query in the Hadoop environment, and then he'll kick off the query in the Delta Lake environment. And it's interesting to see that the Delta Lake, because it's Spark and it's so much quicker than MapReduce, actually finishes before the on-premise, even though the data was generated on-premise. So we'll just let that query run. So he now starts the query. I love doing science. Then he's going to go over to Delta Lake, and we're going to execute the exact same query. And what we're doing is we're counting the number of customers in a given state in the United States of America. So we'll see here shortly, like I said, the actual Delta Lake query finishes before the Hadoop query, even though we started the Hadoop query much earlier than the Delta Lake query. Now what's interesting here is that we can then do an insert of even more data into the Hadoop environment. And what we're showing here is the exact same numbers between the two different environments, but we'll do another insert and query. We'll put another 6 states into the Hadoop environment, and you'll see how quickly we get that synchronized up into the Databricks environment by running that same query. So what this enables you to do, in the grand scheme of things, is run for a period of time in a hybrid mode, where you're able to do your compute on premise until you're absolutely comfortable that you can cut over in totality to a Delta Lake environment. And we can see here now that we've got our new states inserted. We're getting the exact same results in Delta Lake that we're getting from a Hive query on premise. Okay, so this is quite interesting and quite powerful stuff that allows you to make that journey up into the cloud without having to experience any downtime. The data can continue to change while you're making this migration happen. So I started a little bit late, and I'll finish a little bit early for any questions anybody might have. Yes?
How do you maintain state between the two environments? Is this parsing in the background with some sort of...
Great question. So the question is, how do we maintain state between two different environments? What's going on in the background? Is it rsync? What we are is a consensus engine. So we will have our Fusion server sitting, or servers sitting in front of the Hadoop environment, Fusion servers sitting in the cloud, and every transaction gets coordinated between the two. So as soon as I do a put statement in HDFS on premise, that's agreed with the Fusion server in the cloud. The write happens on premise, and then it is pushed up into the cloud as it's being written into HDFS. Any other questions?
The query that you had running earlier, that was it Hive on Tez?
Yeah. Yeah, Hive on Tez, yeah.
And the question, I guess, is related. For the synchronization, does Delta Lake add any reliability on top of what you're currently doing the transactions?
So, yeah, I'm not a Delta Lake expert. I'm not going to pretend to be that. But one of the things that we are currently working on in terms of resilience for Delta Lake is not being able, not just doing Hadoop into Delta Lake, but Delta Lake in one cloud region to Delta Lake in another cloud region, so that you're protected against outages that happen in S3 or happen in Azure. Because last June, for example, North Europe in Azure was 17 and a half hours down. And it's happened to Amazon in my time with WANdisco as well. Yeah.
The product, sold by amount of data moved? Is it sold by time? Is it sold by connection?
So it's, these two guys would probably be better equipped to answer that question, but it is a data volume type subscription license, and that can be a long-term license if you want to run hybrid, or if you're looking to just do a migration, you can get 3-month terms. And if I missed anything...
Yeah, so the key thing on that WANdisco license is not the industry standard 3 times replication level one. We only use the raw data as the count, and then you can replicate that as many times as many instances on the premise of that as you wish.
Great. So I think that's time, isn't it? Thank you very much.
Yeah, let's thank Clayton again. And as with all sessions, be sure to rate and review this particular session. And thanks again, Clayton.